Hello everybody, my name is Mickey Wilson. I'm the Vice President of Operations here at our Mayodan, North Carolina facility. Today we're going to show you a couple of things. First, we're going to show you how our manufacturing methods follow a lean philosophy. We're going to start in LCP, get down into some of the details as to how we manufacture in a value stream format. And then we're going to go into Marlin. We're going to show how that philosophy and that manufacturing method was applied for lever action rifles with our recent acquisition. But first I'm going to highlight, this is a typical value stream. It's a long U-shaped line where we have mostly CNC machines on the outside, followed by an integrated assembly system. And we've set them up in a single piece flow format where we're pulling to standard work. We've got in-process, inline gauging in order to ensure quality. And then we put the gun right in the box, ready for consumer use, right at the end of the line. So it's literally raw bar stock in, finished gun in the box coming out. Each of these lines within the plant, and we have about 10 of them, as you can see behind me. Each of these lines act as a small business unit or a small plant within a plant. They're supported by a dedicated team of supervisors, team leaders, engineers, tool makers, maintenance personnel, all the necessities required in order to make these lines run all the time. And when they break down, we treat it like a paramedic would. It's on the scene, do triage, fix the problem, address the problem. So to accompany that, the business unit leader, or what we call a group leader, uses their daily production board. They not only use that for daily monitoring of production, they also use it to track their normal business metrics such as scrap, tooling cost, customer service returns, and their productivity metrics. Those are important business metrics as we drive waste out of the system and improve our operations so that we can improve quality, improve throughput, and do a better job of serving our customers. So with that, that's kind of the overarching message of how we manufacture. We're going to walk down and take a look at, in the LCP line, specifically a few details, and then we're going to go right to Marlin. So the LCP is comprised of a lot of purchase parts, plastic, pins, screws, right? We don't make those. What we do make is the heart and lungs of the gun. We make the insert, which is the inserted piece with the serial number. That's the substantially completed component of the firearm. We also make the barrel. And we also make the slide. So basically we're making the heart and lungs of the gun, which are the insert, barrel, slide, in the CNC arrangements. And again, we flow down to an integrated assembly system, including test firing the gun. We test fire the gun with our inline snail trap. It's located right here. So parts flow and they never stop. The only time they leave the line is a rack of slides and make a quick trip to our bluing room and back. We keep 3 or 4 racks in process just to, maintain our work and process flow. And then our aluminum inserts go on a rack, and then they make a quick trip down to Greensboro to get anodized, and then back up here to be pulled into the assembly. So let's go in here. So insert start as a raw piece of aluminum plug, okay? They start in this first CNC machine and travel down just about 25 feet, and it's a complete insert, ready to go out to anodize, okay? So follow me. Another key element of our lean value streams is our in-process quality control. We don't have roving inspectors coming around to ensure quality. We put the quality of the product into the associate's hands. And the associate, in between every step of the process, has a set of specific gauges that are there to detect when dimensions get out of tolerance or are close to getting out of tolerance, so that we can make machine adjustments or tool changes. So that's a critical element within our lean value stream, in-process quality assurance. Thank you. So you see we have these red-green indicators also. Those are variable gauges. And to make it easy for the associate to read good versus bad, when the dimension of measurement is within the strike zone, it turns green. When it's outside the strike zone after the part's loaded, it stays red. So if the gauge stays red, the associate will stop because that indicates there's a problem, and then the techs or the team leaders come right to the source and address that problem. So a few more steps. We got 6 to 8 machines worth of processing. As we come down to the end, by the time it hits this last machine in this fixture, it's done in this, when it's completed in this machine, it is a completely machined LCP insert. It's ready to be serialized, and it's ready to go to anodize. So from here, we go right in, after a quality control check, we go right into the laser. And the laser is linked to our Oracle system, our enterprise resource system, and it sends a signal up to the cloud that says what's the next available serial number on our A&D records that needs to be applied to that next gun. It sends that serial number down, it burns the serial number, it takes a picture of that serial number, and it ensures that the serial number was applied to an insert before the door will open. So once it reaches this point, now serialized gun, it's the substantially completed piece according to the ATF, and we track that serial number from this point forward. So from there, we put the inserts in a small batch, and it goes into the tumbler. Okay, we go 12 at a time, dump them in. They're in there for like 10 minutes, and then when we pull them out, we put the inserts on this rack, and this rack can hold the insert, never lets go of it until it comes back ready for assembly. This actually goes into the anodized tank at the vendor, and we have a daily milk run down to their location in Greensboro, and we have constant flow happening every day. So that's how inserts are made. Any questions? Okay. So barrels on the other hand start here, and they flow down about 50 feet or so. Okay, we start with hammer forged blanks for the LCP barrel, and this machine here cuts them off the length. As the barrel progresses down the line, similarly speaking earlier, it progressively gets more completed. So this is the first step after cutoff. After it's done with this operation, we have in-process gauging, as shown here, just like the rest of the line that I've already spoke about thus far. We have our in-process gauge information that's at every step on the line, so the associates know what they're checking, why they're checking it, and they understand the important dimensions and the important quality requirements at each step of the process. And again, the important key point of that is, if there's an issue at any step of the process, we stop. We bring attention to the problem, and the whole line actually stops. And because the line stops, that brings urgency to the matter. So our techs, our team leaders form the issue, fix the problem, understand root cause, and then they resume production again. And that's the intent of having quality between every step of the progressive manufacturing process. This is our second step of the barrel process. This is where we do all the chamber in. We do the breech, the breech form as well as the chamber. This is a completed part. After that, this is a duplicate operation here, but this is a completed part. Basically, it's a two-step process. We cut it to length. We do a turning operation to hit the nose, and we turn it up, and we do the entire back end, all in one holding. So again, after the second step of the barrel making process, we have our inline gauging, and we're just going to kind of watch that accrue. This is happening every cycle. So she's checking a headspace feature right there, which is critical in the assembly of the gun. And you notice her digital indicators turn green, indicating that the dimension was correct. Thank you. Now, after the last step of the process, we actually proof the barrel as a barrel. We don't wait to build it up into the gun to send a proof round down range. We're actually proofing every barrel in this small apparatus. This device is safety controlled. He's standing on a safety mat that won't allow the cycle to start unless he stands there the whole time. Once the cycle starts, it spits 1 round of ammunition out of this hopper. He loads it in the barrel, again, having to stand on the mat all the time, and that ensures the safety of the associates. We control ammunition locations in the plant, but because we got guns spread all over the place, we want to control where the ammunition is at all times. So that's our way to do that. So from this point, it's a proof barrel. It didn't crack, didn't blow up. We're highly confident with it. And then we put the proof mark on, put it into a tumble operation, quick trip to bluing, and it's back at assembly. Literally, once we start a barrel, that barrel will become a finished LCP within a matter of a couple hours. Good job. Now we're into the slide operations. This is the most complicated part out of the 3. So we start with raw bar stock slugs, and we whittle an LCP slide out of this complete. All right? We have a lot going on with this operation. So we have 8 machines doing the same thing. Follow me. We basically load the piece of bar stock in there, and we machine the entire, what we call the belly of the slide. And that is all the critical dimensions, including headspace, is set in this one fixture hole. So from there, again, quality at the source, inline gauging, we do a lot of it. And we're doing it often. We're pulling this line measured by the seconds, not the minutes. And there's a keen understanding of quality at all times. So from here, the very first operation of the slide is done, and then it flows in a single piece format from this point all the way down into assembly. So let's go to the end and take a look at that. By the time we get to this machine, it's mostly a completed slide. This is our Op 45. And it's nearly complete. We've got 2 more operations to go. It's going to get blasted, and it's going to go to the bluing room. So the last step's Op 50 right here. It's our very last machine. We're done with the slide at this point. We do some final quality checks on the last couple dimensions that were applied to the slide. We go to the tumbler. We laser mark the text on the side of the slides, and then we go right to our bead blaster. Okay? We do these in small batches because the bead blasting takes a little bit of time, as does the tumble. But from there, we go on this rack, and once this rack's full, trip to the bluing room. 67 minutes later, it's coming back to the line. So from that point, we're going to flow. We now have a finished barrel, insert, slide. This is the rack of inserts that came back from our anodizer in Greensboro. Again, we haven't touched it. We haven't touched it from the time of manufacture. The actual insert itself, it went on the rack. It never gets taken away from the rack. The only time it gets taken away from the rack is when we're ready to build the gun with it. So from this point, all 3 components are here, ready to go. And then we flow down the progressive assembly system, 1 gun at a time. And the last step here in the process is we have a completed LCP that will go bang. And we do the final headspace checks here, final safety function checks here. And then we put the gun, as we do the barrel proofing, we put the gun in the fixture nest here, right in the line, right in our inline shooting snail, and it sends 3 rounds downrange. That ensures function and safety of the firearm. From that point, we get a green light, gun is good. We pack it out, ready to go to consumer right here on this last bench. So similarly to the value stream operations that we saw in LCP, American Rimfire, singular line, integrated CNCs into a finishing into an assembly operation. We have the same concept in Marlin, but similarly to AR556, where we have so much going on, we have to have multiple banks of machines feeding assembly. Okay, so our Marlin 1895 system currently consists of 3 banks of machines. This is bank 1. It also is comprised of assembly. Okay, so on the back side of assembly, as you can see, that's where all the small parts are made. We touch most small parts in this thing. We're dealing with mag tubes, sears, hammers, tractors. The list is quite long. We've taken a lot of the old World War II vintage machines that we found in Alien that were making all these small parts, and we put them all in CNCs. So we've got a little menagerie of robo-drills and little Haas machines that we're making simple CNC cuts in, and that gets rid of a lot of reliability issues or quality issues. So we've been able to tighten up a lot of our tolerances, which I'll talk about in a few minutes, in order to improve the quality and the function of the gun. So again, bank 1 here, as you can see, we're building trappers as we speak. Okay, we start by torquing the barrel onto the receiver, and it flows around the horn in assembly here in a single piece flow format as the gun progressively gets manufactured. And again, on the back side of it, that's where small parts are. So let's go over to bank 2, which is really where the chassis of the gun starts, and I'm going to walk you through that operation. So this is the second bank of machines. Okay. This is where we make the receiver, which again, it is the heart of the gun. There's a lot going on. If you don't make a right receiver, you don't get good functionality within the receiver. Okay, so we make receivers in most of this bank, and then we make barrels in this last little bit on my right side, your left side. Okay? So I'm going to start with receivers. We're just going to walk it down, kind of hit some of the operations and some of the key improvements. So the receiver process starts with forging. It's the same incumbent forging supplier that Remington was using. We're utilizing them as well. It's the same forging. We were actually using some of the inherited inventory that we got from Remington, but we're starting with the same forging design. These are actually stainless forgings. It's either going to turn into an SBL or a Trapper. We start there and we put it into this first machine operation. First machine operation, we're basically decking the sides and putting in some of the key pivot holes all in one shot. So one important thing with our manufacturing methods are when you have a positional tolerance from hole to hole and something like a hammer pivot to a trigger pivot, very important that you keep the position of those two holes in relationship to one another as tight as possible in space. Okay, so where appropriate, we'll hold apart, not let go of it, let the CNC do the work, and put the right number of holes in it at the right location without transferring that in between processes. So the first operation here, the first two is like we deck side A. That gives us a nice flat datum to bed to for the subsequent operations, and then we turn it over and we deck side B. Anyway, from that point forward, we've got a nice datum to hold on to as we progress down the line. So after the second step of the process, we've got something that has two very parallel sides, machined very flat. The surface finish is actually quite nice, and that was an improvement that the guys made from the process that we inherited from Remington. They had a high level of polishing, hand polishing required on the sides. We're doing a lot more machining on the sides in order to take a lot of that hand polishing away. So another thing, again, similarly, in-process gauging, high level of in-process quality control. Another thing that the engineers took a look at is wood fit. Okay, there were a lot of problems with wood fit in and around the tang, and one of the things, aside from CMM measurement of the profile, which we do often, we put inline gauges such as this gap gauge. Now, if you take a look at this, the operator puts it into this, uses the backlight to ensure that there's a nice even gap all the way around the tang. That's done because the wood will be made to this exact dimension up in our Newport, New Hampshire facility. And we are getting excellent wood fit because we're controlling the tang form, we're controlling the tang size, we're utilizing this backlight so that if the gap gets out of whack, it becomes very evident right away. And in our Newport, New Hampshire facility, we're doing the same thing. We're utilizing a carbide, utilizing a sandy carbide that has that exact form as well. So that we've got a good match at the wood manufacturing process, a good match at the receiver. When you put them together, they work, and the fit's quite nice. And our Marlin butt stocks are interchangeable. You can take a butt stock off of one gun, put it onto another gun, and it's going to be the same. It's going to fit the same. It's going to look the same. And that's one of the key improvements that we put a good effort towards when we inherited Marlin in order to improve the quality to our consumers. So the second step of the operation, where we've already decked the sides, we've got nice two parallel sides to work with now. We put the barrel hole and the mag tube hole in, as well as in mill the bedding surface where the barrel would cinch up to. So from there, we made some improvements to the gauge that was previously used in Marlin receiver making in order to control the timing of our threads better. We also went, from a design perspective, we went away from the channel that used to be underneath the barrel, and that was for mag tube clearance. We're actually utilizing this flat. We went to a flat. We're actually utilizing this flat as a nice, flat, wide wheelbase datum that we can control the dovetail dimensions to, both angularly and position-wise, as well as controlling the timing then of the threads, so that we get an improved torque condition. We've got the threads on both the barrel and the receiver timed in such a way that we want to see about a 24-degree angle on the barrel when it's hand tight. That way, when the torque machine brings it up to top dead center, we're right in that 75 foot-pound range, which is where we want to be. So far, thus far in production, we've not seen any barrels that get over-tightened. We don't see any barrels that get under-tightened. So doing a pretty good job with that these days. So as we progress down the line, again, more of the same, single piece flow, progressive manufacturing of the receiver. It's going to go all the way down to the end and come back around a little bit. Another key element of our manufacturing process, you'll notice as we're walking down the line, there's no inventory either before a process or after a process. We are literally single piece flow, very tight inventory, and the reason for that is if we detect a problem at any step of the process using our inline gauges, we stop the process. That way we don't have any material that's suspect, or a minimal amount of material that's suspect prior to that operation being made. By the time it gets to this area here, the receiver rounds the corner and it comes back. This last operation is where we're putting the locking block slot in with the broach tool. We actually re-engineered the broach tool. We're using a more modern machine that has rotational comp capabilities, and we're putting that locking block slot in there very, very squarely to the rest of the receiver. Again, last few inline gauge checks here, and then we put it into the equator machine. Okay, what the equator is it's kind of a watered down coordinate measuring machine. It's going in there as that last quality assurance check. We're doing this 100%. Okay, so we have good coordinate measurement data on every receiver we're making, and that is to ensure that all geometry inside. We got some pretty critical stuff going on in that receiver. You got locking block slot, which sets headspace. We've got all the lever clearances and functionality, pivot hole, hole-to-hole locations that we got to control. This machine here is that last double check to make sure that all the inner workings of our Marlins are going to be as best as possible. Okay, so from there, we still have a little bit of a okay, so from there, we still have a little bit of inherent machine marks. Okay, the guys did a great job taking as many of the machine marks out as much as possible in order to minimize hand polishing. But one step further that the engineers have recently employed to even further minimize polishing is they put what we're calling the OP 120 sanding discs applied to every receiver. Okay, this is kind of a homegrown tool. It's a spring-loaded tool. It takes a sanding pad. It's an 80 grit sanding pad, nothing special. And we're actually taking it down and we're wiping the sides of the receivers. And that's taken away minutes worth of hand polishing at the 400 grit level. We're actually going right from this last machine. We're going right to a 600 flex paper and finishing it with a 600 cork paper. So from this last step, our ROP 120, where we're using our homegrown sanding disc tool holders, and we designed and made those in-house. We're going right from here. So we've got something that we can actually work with these days with minimal polishing experience. So we start right here with the 600 flex. We're going right from, already a nice flat surface. We got nice crisp edges. We got to condition the corners a little bit with the paper. But this entire deck flat, this entire surface here has been decked flat, and it's been sanded flat in the CNC. So we've drastically minimized the amount of variation that we're going to get with our hand polishing. So we go right from the 600 flex. Then we finish with a 600 cork, kind of forgiving belt that puts that last amount of sheen on there. And then we start polishing the bulges and the tank. Once that's completed, that receiver is ready to be serialized. That is a substantially completed receiver at this point in the normal flow of production. So we go ahead and apply our markings, as you've seen earlier in the LCP. And then we finish it out with more bulge polishing. We assemble the trigger guard, we assemble the trigger guard plate. And then we blend on this buffing jack. We blend the trigger guard plate to the receiver as the last step. From this point here, this is ready to go either to the mass finishing machine for an SBL or the blast cabinets for a trapper. So this is the start of barrel. Okay. One improvement that we wanted to make with Marlin was to go away from cut broach rifling and button rifling. One of our core competencies as Ruger, especially for centerfire calibers, is cold hammer forged barrels. Okay, we do those on these multi-million-dollar hammer forging machines, rotary forging machines, and this is the blank that has come out of that. The bore and the grooves are forged in as opposed to cut. So we have a very strong barrel that will last, and accuracy stays very good for the long term. So we start with a hammer forged blank. We go right into the contour machine where we're putting the taper. We're actually applying the muzzle threads and the crown into that, right in this one machine. Next stop here is we're shooting the chamber in. Okay, we're machining the hub, putting the threads on. This is where thread timing occurs. And then we're shooting the chamber in there. And these last few steps here, we actually secure a timing dog, and that's what this piece is right here. We secure the timing dog to every barrel. We put it into this clamp. This is very similar to what the old process was. We made a few machining improvements nonetheless, but we're still using the process that was acquired. This also sets all those flats to the threads, and that's what gives us good timing. And process gauging here. And similarly to the receiver, we have an equator doing some coordinate measurements for us on the barrel. And again, we're looking for this flat, which again is incumbent to be in the right spot relative to where the threads start, so that we get good thread timing, as well as where the dovetail and the tenon cuts are. We've got good angular position control with this machine. If there's a problem, we stop. What it also gives us is the ability to measure centrality of the hole, where the sight rails go, as well as the front sight goes. So we got good control left and right of the hole. location. If it gets out of whack, this machine's going to tell us it's out of whack. We stop the process, we walk back a few steps and make an adjustment. So from there, the barrel is complete aside from the markings. We go into 2 laser systems. That's applying the point of manufacture, the brand, the model. And then we finish by putting in, we batch up a small amount of barrels complete, ready to go to assembly. Okay? We run very little inventory between steps. We don't have departments piling up parts, shipping it to another department. We have literally a few tubs between here and assembly. So that if there's a problem here, it's going to show up in assembly rather quickly. Okay? So again, I want to highlight, we just walked through receivers, we walked through barrels. I can't express it enough. From the moment that forging that I showed starts, it's going to be a Marlin within a few hours, rather than days or weeks or months. All right, so we just talked about receivers, just talked about barrels. This last bank of machines here, this is where we make our finger levers, our trigger guard plates, and our bolts, okay? Similarly, again, this is all similar, single piece flow up, flow counterclockwise. Our finger lever starts with the same forgings that was being used before, same vendor, same forgings, okay? We went away from a Blanchard grinding process and we put the first 2 decking operations into a CNC. This is a magnetic fixture, so set the parts on there, located by pins. We apply electromagnetic field and pull the parts down. We're doing this with a shell mill. Okay, we're getting very good finish, very good flatness on each side. Pretty good, you know, we're getting pretty good quality measurements with this process. Because we use electromagnetic fields, we have to demag every one. Okay, so we'll go right from this machine, demag the finger lever. We'll move it on down the line. This fixture, the second step of the process, works on what we call the business end. Okay, we've got all these critical features that's critical to the function that has to interact just right with all the internals as well as the receiver. So we do this all in one shot. We're using vision systems to control the profiles of some of these profile tolerances that we need to control pretty tightly. Also inline gauges, again, nothing new. We use these all over the place. If there's a problem, we stop. So we got the lever decked on the sides. We got the business end set, tightly controlled with tolerances. Right here, we're taking the outside profile and we're running a contour mill around it. And it's almost a complete finger lever at this point. Last step of the process here, we've done the outside contour. Now this machine here goes in the inside, gets the finger lever loop, as well as the trigger guard loop. So at this point, this is a completed finger lever. So as you can see, this is a finished finger lever right from this machine. The engineers and the team has done an excellent job of improving our machining finishes. As you can see, this is nice and shiny coming right out of the machines. It needs a minimal amount of tumbling and a minimal amount of polishing. It goes into 2 tumblers for a very short time. It gets a couple of quick hand buffs on the side. And then it goes into this tub right here. Once this tub's full, it goes right to assembly. So again, finger levers start. Less than 3 hours later, it's a Marlin in the box, ready to go to consumer. This is Cassie, by the way. Say hi, Cassie.
Hello.
She's an engineer out here. So this is the start of bolts. This is what we call op 10. It's actually the machine started in mid-cycle. As with our other parts, we either start with forging or raw bar stock, and we single piece flow process it until the end, and it's complete, ready to go to the assembly cell or its next downstream operation. So first operation here, it kind of creates the ears on the back in this collet fixture. This machine stopped mid-cycle, just so you can see where the milling cutter is. It also shoots the firing pin hole from the back, so we got good control of firing pin centrality to the ear. So that sets the stage for the rest of the operation. Thank you. Good job. So from there we do a couple of gauging ops. Op 20, a second step of the process is we grab onto the ears and we bed onto the firing pin hole, the rear of the firing pin hole, and we turn the front end, okay? So now that we got the front end machined, we got a nice round diameter to hold on to. So we're holding on to that diameter and we peel the back end in this turning operation. So now we have good centrality of the outside diameter to the firing pin hole, as well as centrality of the ears. So from there, it's coming out op 20, kind of looking like that. Op 30, we flip the part over. We grab on this nice round machine diameter, and we peel the front end, as well as do all the cartridge sheet work. Again, in process gauging, we check total indicator run out, and that's to ensure that we got a good concentricity measurement between the firing pin and the outside diameter. That keeps everything nice in line in the firearm. And the last operation is the milling cuts. We're putting in various features in this rotary fixture, as well, including the barrel fluting, which is a feature that we added for our 1895 SBL and our 1895 Trappers. This last operation is putting the slot that the finger lever engages with, as well as a couple other critical hole locations. And then from that point, we have a completed bolt. And again, as you've seen with the other parts, we go right into our equator. That's that final, last coordinate measurement check. And that's to kind of double ensure the quality, the in-process quality that we've seen thus far in the progressive manufacturing process. Trigger guard plates, similarly, start with the same forgings as in the past. Same fixtures that we had bought with the acquisition we're using. We've improved some of the machining operations. We've improved some of our tooling and as well as feeds and speeds. So op 10, op 20, in-process gauging, quality at the source. That's kind of a common theme as you have noticed through this tour. Progressing down the line, we've got other features being implemented. So once it's completed with this operation, we have some critical quality control checks of some of the interacting surfaces as well as hole positions. We're using this inline Keyence vision measurement system. And the vision system takes the part, you lay it on this glass here, and it's using vision technology in order to measure features, size, location of all of the critical features that we want to keep quality control with. So the institution of these is recent, and they've done a good job of detecting when quality gets out of whack. Again, the last couple of steps here, more milling, more holding, more progressing. And at the end, we have a completed trigger guard plate. Last few quality checks into the tumbler, into the ultrasonic wash, and one of the few bins that are in rotation. Again, the start of the trigger guard plate, from the time of the start of the trigger guard plate till finished gun in the box is literally within hours. That brings us to our last stop of the tour. You saw the technology that we put rigor to as an engineering team. We talked a little bit about the design and taking the intent back to old Marlin, all the way down to the component and the dimension level. We talked about increasing improving our tolerance band so that we can more precisely make the parts. And the goal of that is to become a product that can be assembled rather than gunsmith together. Okay? And we do that because we want to run it through an integrated assembly process where we don't have employees at workbenches using files and hammers and grinding discs. We want to assemble the gun in a progressive set format, just like we do with machining. So our assembly cell starts right in here, where we polish the barrel. We've got barrels, we've got receivers. We're utilizing our inherited torque machine, and because we put a lot of diligence into understanding our thread timing, The barrels are coming out very good. We have a very controlled situation with our torque. We're measuring pre-torque with this digital gauge, as well as post-torque coming out of the machine. If it's a trapper, it's going to go right into this hand blaster, the sand blaster right here. So we're actually using a glass bead for this finish. The trapper's ready to flow down this assembly system. And each step of the process, as you can see, we have very little inventory, and every station has a purpose. These were built by the Ruger team. This is all brand new. Okay, every station has a specific purpose. Flowing down the line, progressively becoming more complete. And then when we get to this point, we turn around and we measure. Megan, you want to do this? Yeah, can you do it? Come over here. Hang on a sec. Is that one already done? Like,
no, I just started.
You just started? Okay, we're gonna video you doing it. Okay, you're gonna do a check, and I'm gonna talk over you. So go ahead. What Megan's doing here is she is setting. She's determining what size of locking block in order to put into this receiver so that it'll headspace. Okay? The process of build was kind of an iterative process by trial and error. You start with one, you build the gun mostly up, you check headspace. If it wasn't right, you tear it down, you put a different size locking block in. Here, we have a deterministic process where we partially assemble the receiver, the TGP into the receiver with the lever and the bolt. We use traveling pins so we don't have to screw the gun together. There's a measurement that she just determined with that feeler gauge, and she's going to understand by using her gauges here what size of locking block she needs to pick to put into that gun. Right now she has what we call a zero locking block in there. That is a specific width. That's our constant or our central locking block. She measured how far larger or smaller the locking block needed to be in order to achieve headspace after we fully assemble the gun. Okay, and that's why it's deterministic. We can determine what the headspace or what the locking block size needs to be beforehand if we would build the gun all the way up, only to find that it won't headspace and have to tear it all the way back down. Good? You did a great job. You want to smile at the camera? Thank you. Thank you. From that point, put the action, put the TGP assembly all together in one set. That's a match set, and it flows down the line from that point, dropping down into the appropriate assembly station. Rhonda here's putting the final screws in to completely secure the trigger guard plate assembly into the receiver. So we finally arrive at the last station where we assemble the buttstock, do a final headspace check, and put it in this rack. What you have is a fully completed, highly engineered, highly manufactured, precisely 1895 trapper ready to go to the range. So after we have a final 1895 trapper or SBL or any 1895 Marlin, the next step that occurs is, I told you it was ready to go to the range. So we get a final inspection check. This is Will, he's one of our final inspectors. He's checking the outs. And then once we go to the range, we get proof. We got a proof stamp. We put function range down. We're bringing them back in. We're doing another final assembly or final safety check. We're doing another final safety check. Once it passes this station right here, we bring it right around the corner. We transact it into the box, and that 1895 trapper is ready to go to the consumer. So final inspection is done at this point. And another visual check, make sure it looks good. And then we're going to put the 1895 trapper, dress it up with some tag swag, put the manuals in the box, and transact it into our system. It's ready to go to the customer.